All right, guys, here are our 5.2 notes, and we are going to talk about some properties of shapes here, specifically looking at quadrilaterals. So we talked in 5.1, we did some polygon angle sums. Polygons are many sides where we can have 20-sided shapes even, or 6-sided hexagons, or 5-sided pentagons. So quadrilaterals, hopefully, a word maybe we kind of recognize, okay, to mean that these are shapes that have 4 sides. So all of the shapes that we're going to talk about in this section are 4-sided shapes, quadrilaterals. And then we're going to talk about different properties that make quadrilaterals specific types of other shapes. So first type of shape we're going to talk about is called a parallelogram. Again, hopefully a word that we recognize as having talked about before. And if we have a quadrilateral that has any of these 5 properties, then we can classify it as being a parallelogram. So here's the 5 properties that make a quadrilateral a parallelogram. Okay, they have opposite sides that are parallel. Opposite sides are parallel. They have opposite sides that are congruent. Whoops. Opposite sides are congruent. They have opposite angles that are congruent. They have consecutive angles. Consecutive means right next to. They have consecutive angles that are supplementary. Supplementary, as we reviewed in Unit 1, means that they add up to 180 degrees. And they have diagonals. So diagonals are segments that go from vertex to vertex across a shape. They have diagonals that bisect each other. So if you have a quadrilateral, a 4-sided shape that has any of these 5, then it is a parallelogram. And the most defining characteristic potentially there, right, is that opposite sides are parallel. That's why we call it a parallelogram. Because then on the other side of our quadrilateral classification here is trapezoids. And trapezoids only have 1 pair of parallel sides. So instead of having both pairs of opposite parallel sides, trapezoids only have 1 pair of parallel sides. And then if we have a shape that, if we have a quadrilateral that doesn't have any parallel sides, then it's just a quadrilateral. It's not any more specific than that. Okay, but trapezoids have 1 pair of parallel sides, and then they also have consecutive, or they have same side interior angles, which we also sometimes call consecutive interior angles. Turn my air off. So this is a property that they have in common with parallelograms, but trapezoids' distinct property is that they only have 1 pair of parallel sides. And then what we do have in trapezoids that we don't have in well, we have it in triangles, but we don't have it in parallelograms, is we have a midsegment. So we just talked about midsegments in Unit 4 with triangles. Okay, a trapezoid, I saw someone described a trapezoid as a decapitated triangle, right? It's a triangle without the top point part. So trapezoids also have midsegments. And to find the midsegment, to find the value of the midsegment, we have a formula for it. And that formula is we take the length of one of the bases of the trapezoid, we add it to the length of the other base, and then we divide by 2. And we're going to do some more problems with solving for these values. But we're just collecting all our information about our shapes in this graphic organizer here. Okay, so then we have quadrilateral, we have polygon. Whoop. Polygon is kind of our biggest classification. Then within polygon, if we have 4 sides, it's a quadrilateral. And then under quadrilateral, we get even more specific. We can either have parallelograms with 2 pairs of parallel sides, or we can have trapezoids with 1 pair of parallel sides. And then under each of those classifications, we can get even more specific. So under parallelogram, we have rhombuses. And rhombuses have all the properties of a parallelogram because they're in that same family. But rhombuses also have 4 congruent sides. They have perpendicular diagonals. So remember that perpendicular we defined last unit to mean that they make right angles, right? And that upside down capital T means perpendicular. And then they also have diagonals that bisect the angles. So their diagonals still bisect each other, but then rhombus's diagonals also bisect angles. They bisect the angles of the rhombus. So rhombus, 4 congruent sides, perpendicular diagonals, diagonals that bisect angles, and also the diagonals of, or the properties of a parallelogram. So everything in the parallelogram family has all these properties, has the 5 properties of a parallelogram. So those are the rhombus's distinct properties: 4 congruent sides, perpendicular diagonals, diagonals bisect angles. A rectangle's distinct properties is that it has 4 congruent angles, right? So they all end up being right angles because they are congruent, and they have to add up to 360. And then they also have congruent diagonals. So again, those segments that we will draw or see across our shapes in a rectangle, they are congruent. And then the most specific shape that we have under quadrilateral and under parallelogram is a square. Now I kind of like to call the square the junk drawer of parallelograms. So you guys have a junk drawer at home, kind of that drawer in like the kitchen or the office that just everything goes into. You've got pens, you've got rubber bands, you've got envelopes and mail and all this extra stuff that you don't really have any other place for, so you just put it in your junk drawer, right? A square has all the properties of a parallelogram, all the properties of the side, and all the properties of a rectangle. So a square just gets it all, like a junk drawer. Rhombus and rectangle. So if you have a property, most likely a square also has that property because it just gets everything. Now, it is the most specific, so it also has the most requirements that need to be met in order for us to call something a square. So those are the more specific types of parallelograms. And then under trapezoid, we just have one more specific type of trapezoid, an isosceles trapezoid, which we can guess isosceles. We know isosceles triangles have 2 congruent sides, and isosceles trapezoid has 2 congruent sides. Okay, so trapezoid, just so we have a visual that we know we're working with here. Okay, here's our trapezoid, right? Here's our base, here's another base, and then the little pieces on the sides are called legs. So with an isosceles trapezoid, the legs are congruent, the base angles are congruent. Again, this is only with an isosceles trapezoid. and the diagonals are also congruent. Diagonals are congruent. So this is a property that it does share with rectangles, but a trapezoid obviously is not a rectangle because it only has one pair of parallel sides. So we got a lot of different types of shapes here, a lot of different properties. We collected them all in this graphic organizer, and I would encourage you guys to keep track of this as we go throughout this unit, because we are going to keep referring to, well, is this a rectangle? Is this a square? We got to try to classify what type of shape it is. So we're going to look here based on the information we have, not what it looks like, but based on the information we have, what can we classify these quadrilaterals to be? So on the first shape here, the only information we have is that we have opposite parallel sides. We don't have it looks like a rectangle. I know a lot of us are going to say, oh yeah, it's definitely a rectangle. It looks like it, okay? We got to be more specific now. We can only state what we know to be true for sure, okay? And so the only thing that we know for sure about this shape is that it is a parallelogram, because it has two pairs of parallel sides. On the second shape, we have two pairs of parallel sides and one pair of opposite congruent sides. Again, the only specific information there, all we have for sure, is that it is a parallelogram, because we don't have, oh, I spelled parallelogram wrong on the first one, you guys. We don't have any information that makes it specific to parallelogram. Right? We want to call it a rectangle. If we want to call it a rectangle, we have to know that there are four congruent angles or congruent diagonals, and we don't know that. So all we know for sure is that this is a parallelogram. And because it has two pairs of parallel sides and one pair of congruent sides. Okay, on the next one, we have four congruent angles and four congruent sides. So we look, four congruent angles is a property of rectangles, and four congruent sides is a property of rhombuses. So because it has a property of both a rhombus and a rectangle, then we have to call this a square, because that is the only shape that has all sides congruent and all angles congruent. Okay, on the next one here, we have these two right angles. Now that doesn't give us a whole lot of information. However, it does tell us that we have same side interior angles here. These are same side interior angles. And because they're both 90, that means that they are supplementary, which tells us that this side is parallel to this side. So with the information we have, we know that we have one pair of parallel sides, which means that the best classification that we can give this is we can call it a trapezoid, because we have one pair of parallel sides. And we could actually even also call this a right trapezoid, because we have those right angles. Okay, so you kind of get the idea. We are looking at our shapes based on the information we know. What can we classify it as? Okay, next shape, we have one pair of congruent opposite sides. Both trapezoid and parallelogram require us to know that we have parallel sides, either one pair or two pairs. So the best classification that we can give this is simply quadrilateral, because we don't have any of the properties that are more specific to our shapes. On our next one, we have the 65 and the 115 and 65 and 115. We have one pair of parallel sides here. And we know that our base angles are congruent because we can see the angles sitting on our bases here, 65 and 65 and 115 and 115. Those are congruent. So the most specific classification we can give this shape is an isosceles trapezoid. Because we have one pair of parallel sides and congruent base angles. Okay, next one we have three 90-degree angles, and we know it's a quadrilateral, so this angle must also be 90 so that they all add up to 360. And then we have four congruent angles and four congruent sides, so we can call this a square. Okay, next one we have diagonals bisecting each other. That's what these little congruent tick marks mean, okay? And also because they all have just one tick mark, that means that our diagonals are congruent. And we also have this 90-degree angle in here, showing us that our diagonals are also perpendicular. So if we go up and look at our shape here, or at our properties, okay, diagonals being perpendicular is a property of a rhombus, and diagonals being congruent is a property of a rectangle. So again, if we have properties of both a rectangle and a rhombus, then we must classify this as being a square. Okay, then the shape has one pair of parallel sides and it has a congruent base angles. So we have congruent base angles and one pair parallel sides. So the best classification we can give this is as an isosceles trapezoid. Okay, on the next shape we have, again, diagonals bisecting each other, and because they all have one tick mark, that means the diagonals are also congruent. So we have diagonals bisecting each other, which is a property of parallelograms, and we have diagonals that are congruent, which is a property of rectangles. So the most specific classification we can give this is that it is a rectangle. Okay, this one is just like the one we did 2 times ago, so I'm not going to do that. Okay, on this one we have 56 and 124, which are supplementary. So we would know that these sides, A, B, and DC, are parallel, making this a trapezoid. Okay, so here's what we need to caution and watch out for, is a lot of us are going to look at these shapes and go, yeah, it looks like this, so it's this, okay? You can use "it looks like" to get you on the right track, but we need to make sure, because we are big bad 10th graders in Math 2 now, right? We are no longer 4th graders learning about shapes. Now we are 10th graders learning about proving things. So what we have to make sure that we are doing, or I guess 9th, 10th, or 11th, whatever grade you're in, okay, we have to make sure that we are actually proving why these shapes are what we think they look like. All right, so we are going to stop there. You can maybe try these next 4. Leave the table for now. Well, I guess you could try it too if you want, but we will go over those in class.